Okay, this video is about mass and weight and also resultant forces. So your learning objectives are to know the difference between mass and weight, to know how to calculate weight using the equation, know what is meant by resultant forces, be able to understand and draw free body diagrams, and also be able to draw vector diagrams for forces. Okay, so the first two, knowing the difference between mass and weight and knowing how to calculate weight using the equation. It's all really just in the spec, and it's been covered before in the energy unit where you calculate weight. Without reading it all through, you can pause if you want to do that. Weight is equal to the mass times gravitational field strength. Weight is a force, so it's a vector, whereas mass is a scalar. Mass is measured in kilograms, weight in newtons, so multiply mass by gravitational field strength to get weight. And questions on this, if it's on the Earth, you will be given what the gravitational field strength, or G, is, which is 9.81 newtons for every kilogram on Earth. You'll be given that in mass, so if you calculate the weight, for example, an 80 kilogram body would have a weight of 80 times 9.81, which is about 800 newtons. The last thing there is that a weight may be considered at a point which is called a centre of mass. If you want to find out more about weight, force and mass, an excellent video from the Fuse School is force, weight and mass. So the second objectives are knowing what is meant by resultant forces and being able to understand and draw free body diagrams. Another good video for you to watch is the Fuse School Force Resultant Forces, which is about 5 minutes long. Basically, resultant forces are when you add a number of forces together, taking into account its size and also its direction. And for higher tier, you must be able to describe examples of forces acting on an isolated object and use free body diagrams. And finally, we'll come on to the end, a single force can be resolved into different components. So this slide shows you how forces are added together to get a resultant force. So the first two are quite straightforward. If the forces are in the same direction, the same plane, then they'll just be added together. So two 10s would have a resultant force of 20. In the third situation, they're in the same plane, but they're equal in opposite directions, so they cancel out. So the resultant force would be 0. That would be a balanced force. And then the fourth example, right angles to each other, you can then have to add them together, and we're going to come on to that, but basically you could use Pythagoras, and you could have 10 squared plus 10 squared would equal to 200, and then the square root of 200 would be 14.1 at an angle of 45 degrees. Similarly, if the force was acting the other way. And the last one there is showing you, and you can work that out for yourself, is if you have them like that, you'll get a 10 Newton force upward. You'd have to do a scale diagram or know the angles for that one. Another way of doing it is if the angles are not 90 degrees, they're an angle, you can use what's called a parallelogram of forces. So if we have two forces, F1 and F2, at a 60 degree angle, you could draw them to scale. For example, 1 centimeter representing every 10 newtons. Therefore, you'd have 5 centimeter along the bottom and 4 centimeters an angle of 60 degrees. And then complete the parallelogram and then find the resultant force, which would be from P to B. Measure that, and if that was 8.7 or 8.7 centimeters, then it would be 87 newtons. Okay, drawing vector diagrams. You should be able to use vector diagrams to illustrate resolution of forces, equilibrium situations, and determine resultant of two forces to include both magnitude and direction. To do this, here's the example. If you have a 3 Newton and a 4 Newton force, this is a free force diagram, then you could draw a scale diagram. So shown on the graph paper there, 3 Newtons using the 1 centimeter per Newton would be 3 centimeters up, and then 4 centimeters represent the 4 Newtons horizontally. And then if you draw a scale diagram and you measure the hypotenuse of that triangle, 3-4 triangle, you'll get 5 centimeters, which would represent 5 newtons. To confirm that, I made the numbers easy for Pythagoras. 3 squared is 9, 4 squared is 16. 16 and 9 is 25, and the square root of 25 is 5 newtons. So I've given you this worksheet for you to try out, and in another video I've got the answers and explain the answers to these questions. Hopefully this has helped you to understand these concepts.